So we want to find the closest integer to the square root of 47. So when you think about it, square root of 36 is 6. Square root of 49 is 7. So 47 is closer to 49, so the square root of 47 is closer to the square root of 49. So 7 is the closest integer. We want to simplify the square root of 48. So we want to think of perfect square factors. 16 times 3 is 48, and the square root of 16 is 4, so we get 4 root 3. Now you might have seen just a factor of 4, like 4 times 12. Then you could have found another factor of 4 later. Eventually you can get to 4 square root 3 that way as well. Number 3, we're adding like radicals, so 5 square root 7 plus 8 square root 7 is 13 square root 7. It's the same idea as like terms, like 5x plus 8x is 13x. Same idea. On 14, we've got the square root of 14 times the square root of 14, so that's the square root of 14 squared. Square root and squared undo each other, get rid of each other, so we just get 14. On number 5, I really don't want to multiply the 45 and the 5 because it would be a really big number. But I can think of a perfect square factor of 45, and that's 9. And so the square root of 9 is 3, so we have 3 times the square root of 5 times 4 times the square root of 5. 3 times 3 is 9, so we have 9 square root 5 times 4 square root 5. Multiply those together, 9 times 4 is 36. Square root of 5 times square root of 5 is square root of 5 squared, or you could say 25, which is just 5. So we have 36 times 5, which comes out to 180. Alright, here we have the square root of a fraction. That's equal to the square root of the numerator over the square root of the denominator. This one happens to be really easy to take the square root of. Square root of 25 is 5. Square root of 81 is 9. So we don't have any radical in the denominator. Here we don't have like radicals at this point. But 3 times 15 is 45, so now we can see those like radicals. And so we can go ahead and combine the negative 1 square root of 45 plus the 8 square root of 45, that's 7 square root of 45. And now I'm thinking about perfect square factors of 45, and 9 is one of those, or is the only one, I guess. So 9 times 5 is 45. Square root of 9 is 3. So we have 7 times 3 times the square root of 5. So that's 7 square root of 5 plus 21 square root of 5. So we get 28 square root of 5. And we're adding like radicals there. So we add the numbers in front of the radical and keep that same radical, same square root. Here we've got x squared equal to 144. To get rid of squared, we'll square root. If we introduce square root into the equation, we have to do positive or negative on one side, and we'll do that on the simpler side. Square root of 144 is 12, so we have positive or negative 12. Alright, we're solving a quadratic equation here, but we only have one x term, an x squared term in the front. To get rid of the plus 9, we'll subtract 9. So we have 2x squared equal to 128. To get rid of multiplying by 2, we can divide both sides by 2. And so we have x squared equal to 64. To get rid of squared, we'll square root. And so we'll do positive or negative on one side. So we have x equal to positive or negative square root of 64 is 8. So we have positive or negative 8. So that concludes part 1 of the review. I'll do a second video for part 2.